Right, good morning everybody. Welcome to the last lecture of DSCI 513. So yesterday in the lab I noticed that there were still some doubts and confusions about the relationship between the MongoDB Compass application and also the Atlas Cloud and also the local instances that you might run. So I'm just going to explain or review things in a few minutes, and then afterwards we're going to get started with the lecture. So MongoDB, like most other database management systems, works based on the server client model, meaning that the database management system itself runs a server that responds to requests made by clients over a network. This is why when you install MongoDB on any computer, whether it be your local computer, your own machine, or a server, it runs a program that is ready, listens for requests from clients. So for example, if you have your cluster, your MongoDB server installed on a cluster, then over a network you can send requests to that. That request can be sent through any client like PyMongo or the Compass application or the MongoDB shell. So it doesn't really matter how you send that request. The server is there to respond to your request. The other thing that doesn't matter is whether the server is on your local machine or on a cluster somewhere else. You still connect to it over a network using an IP address, using a port, and then the server is listening on that port on that particular address, and it will respond to your request. So I've seen people that have set up their own local instance on their computers, and they were also still trying to connect to the remote database. That's not necessary. You either install MongoDB on your own machine or you connect to the cluster. One of these options is something that you need to do. The other thing was confusion around the Compass application. So the Compass application is nothing but something similar to pgadmin that we had for Postgres. So this is just an interface, another client to send requests to the database management system, to query the database, and so on. So this is similar to any other interface that you might use to connect to a database. You have an interface similar to what you have in Compass. So here I have access to my different databases, for example, the movie one here. You have kind of a similar interface here if you do browse collections on the Atlas control panel, but it's not exactly the same thing. It looks the same, but it's not exactly the same thing. For example, here you have access to this schema tab, which allows you to view as kind of a summary statistic of the different fields that you have in the data set, the kind of data that you're storing, the data types. So this application provides kind of more let's say more functionalities compared to what you have in the MongoDB Atlas Cloud control panel. So just wanted to make sure that's clear. So the other thing was that if you're still having trouble connecting to the database in the correct way, you need to make sure that you have defined a username and a password here on the cloud if you're connecting to the cloud. And you have to make sure that you give Atlas admin privileges to your user. Otherwise, you might run into some problems for some of the commands that you might run. Okay, so make sure you have defined a user with this particular kind of privileges, Atlas admin. That's necessary. The other thing is that you need to set this network access to 0000 in order to be able to connect to your database from anywhere, from any network. So some people have set this up to something like this, at current IP address. And when I do that, I will only be able to connect to my database from the Wi-Fi that I'm right now connected to, only from this network. However, this tells MongoDB that I should be able to connect to the database from anywhere. Okay, so these were the only two things that were left I wanted to discuss today. All right. Okay, so with that said, let's get started with the lecture. So in the last lecture, we've talked about NoSQL databases in general, their differences compared to relational databases, and then we started using MongoDB a little bit, and we started writing basic queries in MongoDB. However, we really didn't go into much detail about writing relatively complex queries, and this is what we're going to be doing in this lecture. So today we're going to learn about different operators, conditional operators. We also talk about querying arrays and subdocuments in MongoDB. And also finally, we will finish with discussing aggregation pipelines, which is a very important tool in our MongoDB toolbox. Okay. So first thing, operators in MongoDB are defined using this $sign. For example, we have an operator $sum, which is used in aggregation pipelines to sum values. Or, for example, we have this $GTE, which is equivalent to this greater than or equal sign in SQL that we have already seen. In general, we use operators in MongoDB using this $sign. So whenever you see that, that's not just the name of an attribute, that's not a string literal, it's an operator. So let's see how that works. Okay, comparison operators. So similar to these operators that we have in SQL, greater than, equal to, or smaller than, equal to in SQL or Python, we have GT, greater than, GTE, LT, less than, and LTE, less than or equal to. For example, if we want to return documents whose runtime is greater than 200 minutes, we will write a query that looks like this here on the screen, so the runtime attribute, and then we define a condition on that attribute. We say that we want that attribute to be greater than or equal to 200. And again, notice that conditions or queries themselves also look like JSON documents. And this is always the case in MongoDB. All right, so if you write this query, here you can see that I have applied that condition. I'm working on the runtime attribute, and I'm specifying that I want the runtime to be greater than or equal to 200. And when I run this query, this is the result that I get. As expected, all of the runtime values are greater than 200. Okay, so you have to be careful about these curly brackets. It won't work if we do something like this. You have to be careful that you include those curly brackets whenever you use those conditions. Okay. Another question over here, how many documents are there with a runtime of 200 minutes or greater? And then what we can do is that instead of using find here, we can directly call this method count documents, and inside of count documents we can have a filter, just like we have in the find method, and then again we use the same condition, and it says 227. And this is one method that you should use in the lab questions, count documents. There is another way to count the return documents using aggregation pipelines, but this is usually the more concise version of counting if that's the only thing that you need to do. Okay. Another operator, not equal, which is equivalent to this notation in SQL that we've seen before, or the exclamation mark equals in Python, meaning that we don't want something to be equal to something else that we specify. For example, here the question says find the title and type of 5 documents in a movies collection that are not of type movie. So here I specified this condition on the type field. I say that this field cannot be equal to this string movie. And then when I run this, I only return 5 documents, And you can see that the type of all of these return documents is series instead of movies. And this is what I wanted to do. Again, notice this dollar sign here. This means that this thing that I have written here is an operator. Any questions? Okay. Okay, again, another operator that we have seen in SQL, in and not in, with pretty much the same application that we are already familiar with. For example, here, we're returning the title, production year, and the cast of these movies that I have listed here. And what we do is that we set this condition on the title attribute. We say that whenever the values stored in this attribute are one of these in this list, then you should return the document to me. And here we have a list of values. And notice that for a list of values, we use square brackets. So whenever title is equal to any one of those, that document would be returned. As you can see, okay. All right, not in, similar thing, just the opposite of what we've been doing with in. It just specifies that this, whatever field we're working on, cannot include any one of the values inside of a list. Here, we want to find movies that are not available in any one of these languages, for example. Notice this not in operator, NIN. And then, yeah, here we're just counting the number of movies in the database. So we have 23K documents for movies, and out of that, about 5,000 movies are not available in any one of these languages. Okay. Now, let's talk about logical operators for a bit. So in MongoDB query language, whenever we specify multiple conditions on an attribute, that will be an implicit AND condition. For example, if I have the year attribute here, and I say that the year should be greater than or equal to 2000 and less than or equal to 2010, this means that both of these conditions should be satisfied in order for a document to be returned. So this is an implicit AND. So we don't need to explicitly use like an AND operator. Okay. However, sometimes we might actually need to use an explicit AND operator. In those situations, we have this $ AND, which does exactly what it looks like to do. So we can specify multiple conditions inside of a list, and then all of those conditions need to be satisfied in order for a document to be returned. For example, if we have a field called high rated voted, meaning that we have a condition on the rating as well as on the number of votes, then both of these should be true in order for the document to be returned. And in this case, we use an explicit AND condition. Okay. Okay, so this example here, using the sample supplies database, return 2 documents associated with sales that are made in Seattle and use the coupon. So 2 conditions, we can write it either like this, 2 conditions on 2 different attributes, both of them have to be true for the documents to be returned. And then that's what we see here. We can also write the same thing using an explicit AND, like that. So inside of square brackets, we list as many conditions as we like that we want them to be all true. Okay. Yes.
So I noticed in the previous code that you did the filtering in the projection.
Yeah.
Instead of doing the filter and then project, and that's fine. In the one above.
The one before this one?
Yeah, in this one, so it was within the project.
Yes, you're right. It's within the project. So in this case, it actually returns either true or false, not the documents that satisfy this condition. Yeah, I didn't notice this project here. So yeah, in this case, we're interested in the Boolean value of the result of this one. So we have to use an AND operator to get that Boolean value. Right, yeah, good point, yeah. Okay. All right, so this is an important one. So using the sample supplies database, find the number of sales made between October 1st, 2014 and December 1st, 2014. So the first way, the first thing that might come to mind in order to write this query is something like this. So sale date greater than this date, this particular date, and less than this particular date. However, the thing is, when we specify multiple conditions for a field, all of those conditions should be put into a single query document. This is actually correct. However, we might write it like that because we say, okay, this is one condition saying that this should be greater than that date, one condition saying that this is supposed to be less than that date. However, if we do this, this actually does not return correct values, and we should be careful about that. So whenever we want to put multiple conditions on the same field, we shouldn't repeat the conditions like this. This only looks at the last condition, not on both conditions. We should write it like that over here. So that field should appear only once. And inside of square brackets, we should list as many conditions as we want. So this one over here would return incorrect results. It will only look at the second one. So notice the difference, only referring to the field value, referring to the field name only once. However, we are referring to the field value twice. Okay. Any questions here? Yes. This one. Yeah, the thing is MongoDB doesn't give an error for that condition. I don't know why. We just have to be mindful of the fact that we shouldn't define multiple conditions on the same attributes. Yeah, it's just basically design of the database management system. Yeah. There are certainly reasons for this, but yeah, I'm not aware.
So for this case, if we use a logical AND,
Pardon me?
if we use logical AND,
That would work. Yes, that would work. But just putting that as two separate conditions like that and mentioning the field name twice, that doesn't work. Yeah. Okay. Similar to AND, we also have an OR operator. Again, something pretty similar here. So I'm just going to show you the query over here. We have the OR condition, the OR operator, and then inside of square brackets, we can list as many conditions as we like. Again, very similar to the AND operator, nothing special here. So I'm not going to spend too much time on this. Okay, and finally we have the NOT operator, similar to SQL or Python. This is used to negate a Boolean expression. So, for example, if we want to match field values that do not follow a particular regex pattern, then we can say, okay, this is our pattern, and we don't want it to actually look like that. So In that situation, we can use not. We can also use regex itself, but this is also another option. Okay. Now, another actually very important operator here exists, and this is not the same as, this doesn't do the same thing as the exists keyword in SQL. It's a different thing. So in a NoSQL database like MongoDB, we have a document that has a number of attributes in it, but we've learned that it's not necessary that all of the documents actually have all of the attributes. So some of the documents could have, let's say, 2 attributes, some others could have 20 attributes. And in that case, it is sometimes necessary for us to know whether a particular attribute exists in a document or not. Let me show you why that's the case in this example. So for example, suppose that I want to select or return documents for movies that are not available in English. However, I have to make sure that the languages field exists. Otherwise, I might just filter out English movies that simply don't have the languages field. So we might have a document for a movie that's actually in English, but it just simply doesn't have that attribute in that document. So we simply don't have the language attribute. So here, this is the correct query. So I say the languages field, it shouldn't store a value equal to English. Okay, that's fair. However, I also want that field to actually exist, and then I want that condition to be satisfied. So this is correct. However, let me comment this exists and then run this again. So here, for example, let's say this one, okay? The way that MongoDB looks at this, it says, okay, the languages field of this return document does not equal English. That's right, it doesn't equal English because it doesn't exist, right? It's not because something exists and it's not English. So we have to make sure that the field actually exists and then check whether the value is equal to something or if it's not equal to something. So this is why if we enable that condition there, now this time it returns correct values. So in all of these return documents, the languages field exists and none of the values inside that is equal to English. Questions? Okay. So again, this is because of the nature of NoSQL databases. Yes? You mean between filter projection? Yeah, okay, so in this particular syntax, the filtering will be done first, and then the sorting will be done, and then projection, and finally limit. So it's kind of a natural order of doing things. However, when we discuss aggregation pipelines, we will see that we can actually overwrite this natural order. Yeah, not actually top-down, because this is just a Python function. We can actually switch the order of the named arguments, but it doesn't actually change the order of execution of things. Yeah, so you can actually put limits at the top. It still runs, but it doesn't do the limit first. Yeah. Okay. All right. Okay. Pattern matching with regex, again, something that we're already familiar with from SQL. Super simple to use. We can say, okay, I want my title field to follow this particular regex pattern, and we should be careful, again, about the $. That's what makes it an operator. So we have $regex, and here we have our pattern. Run the query, and it will give you what you wanted. So for example, here we want to return movies whose title contains 3 digits, and this is what I want to have here in this pattern, and I don't want it to start with the digits. And the documents actually all follow this pattern. So straightforward, I guess. Okay, another example. Return 10 documents for movies whose title does not contain any letters. So here my regex pattern specifies that I need to have alphabet letters. However, with this not operator, I'm negating that condition. And then you can see that all of these return documents, these movie names, none of them contain any alphabetic letters. So a use case of not, I know that we can actually write this in the regex pattern itself, but just an example. Okay. All right, so this was the usage of basic operators for querying MongoDB documents. Now let's work on a little bit more advanced stuff in terms of querying documents. So in MongoDB, one of the things that's actually really useful is that it has documents in MongoDB have a flexible structure, meaning that each attribute is not just limited to storing, let's say, single atomic values. It can also store like lists or sub-documents. So let me create a toy database called MDS here. You don't need to check out this code. Actually, this is just a bunch of data. I'm just creating a small collection here. Let me run that. Okay. And then inside of this database, this small collection, this is my data. So for example, this is the database, MDS, and then I have a collection of instructors. And then for each instructor, I have a name and a department, and also the courses that instructor teaches, and so on. So again, here, this is me, departments, okay, courses here, and then name again, department, courses. And you can see that although, for example, this field is just a simple field, it has a name and a value. However, this department field is more complex. So the department field itself stores a document, a sub-document by itself. So inside of that sub-document, we again have attributes and values. So this is what makes MongoDB documents very, very flexible to store complex data. And another example here is this field courses, with actually stores a number of sub-documents, not just one sub-document. So here we have a list denoted by these square brackets, and inside of that, each element is actually a document by itself, a document that represents a course, the course name, and the course code. So that's one course, that's another course, and both of these values exist within this field courses. Okay. So because we can have structures like this, it's important to know how we can query sub-documents like this. For example, if I want to find instructors that teach a course with a certain code, I want to be able to do that. So this is what we're going to be discussing here. Okay. All right, so suppose that we're looking for instructors who work for the statistics departments. If I do this, we know that this department's field over here, it has an attribute called name by itself. Okay, so we might want to run something like this, department, and then name, colon, statistics. However, this would fail because whenever we do something like this, MongoDB looks for an exact match, meaning that it looks for documents that have exactly this thing over here in their data structure. So if here I had this, then it would match this query. However, because I have something else in addition to what I specify in the query, it wouldn't work. So in this case, I have to supply the full department sub-document, and if I do that, it will return that document to me. Okay, so there are these two instructors, Alexei and Rodolfo, who work for the statistics department. And notice that here, this is the entire subdocument here along with the field name. And this is what I have specified over here. Okay. Okay. So this one wouldn't work, however, because it's looking for an exact match. However, the second one works. Now, what should we do if we don't know what the exact, what the subdocument exactly looks like? Okay. One way to deal with this is to use the dot notation. This is something provided by the MQL, MongoDB query language. So, for example, we know that the department field contains subdocuments, and those subdocuments have another field called name. So we can do department. That name should equal statistics. And in that case, it runs fine because here the department field has a subfield called name, so we can access that by using the dot notation. And in that case, MongoDB doesn't look for an exact match. It just looks for a match for that particular subfield that we're querying. Okay? All right. And again, this one also has statistics in its department.name subfield. Okay. So in this case, if we happen to add other attributes to the department field over here, over time, the database changes, the data changes, we add other information in there, then our query still stays robust. It doesn't break because we have used the dot notation. If I use this exact same thing here as my query, then as soon as I add some other fields to that, then my query breaks. However, if I use the dot notation, I'm only querying a particular subfield, and in that case, it will always work as long as that subfield exists. Okay. All right, questions about querying subdocuments and subfields? Yes.
If the name has another layer inside, so do they also look for an exact match?
Yeah, okay, so yes, as long as you don't use the dot notation, it will look for an exact match. But you can continue using the dot notation for how many layers that you want to do that, yeah. Okay, so the takeaway, whenever you want to query subdocuments, you can use the dot notation unless you want an exact match. All right, so another structure that we have already seen is when we have arrays as the value of certain fields. For example, here you can see that this languages field does not store just a single value, it stores a list of values. So it's not a subdocument, it's just a list of elements, list of items, okay, similar to a Python list. So how can we query arrays? Okay. So the thing is, whenever we're looking for one value inside of an array, then we can query that just as we query any other simple field. So here, for example, I say that return any document to me that has this string French inside of the languages field. Whether the languages field is a simple field or it's an array, it will work on that. So you can see here, for example, we have 2 values inside of that list, and that document is still returned, it still works. Here we have a bunch of values, that document is still returned because there is one value inside of that array that is equal to the string that I have listed here. Okay, so whenever I list only one single value, this will work. Okay, however, if I'm looking for more than one element, and if I specify the elements inside of square brackets, then again, similar to subdocuments, it's gonna look for an exact match. So if I say that I want to return movies that are available in these two languages, English and French, if I write it like this, you can see all of the return documents have exactly that particular array for their languages field. So that should be an exact match. You can see that if I actually comment this out and then run this in a different order, look at the name of the movies, this will change. Because again, this looks for an exact match, and the order matters here, okay? So as soon as you use a collection object, like a square brackets or a subdocument, MongoDB looks for an exact match. That's the rule. Okay. However, there might be a situation that I'm looking for movies that are available in English and French, and also in other languages as well. I just want those documents that have English and French listed in them. I don't care about other things. That's okay. They can be available in other languages too. So how can we do that? Okay, we'll learn about that in a bit. But let me just tell you that we can, for arrays, we can also access elements inside of that array using an index, just like in Python. So languages.0 means go and grab the first element inside of an array, and I can put a condition on that element. This is useful for cases that we have a certain order within the items of a list. So this is, again, something that we can use. Okay, you can see that in all of these cases, Italian is the first language listed in this languages field over there. Okay. All right. Okay, so this is what I was talking about. If I want to return all movies that are available in both English and French among other languages, and we don't care about the order, then we can use this keyword, which is useful for querying arrays. $all, meaning that I want all of these items to exist in the list that is the value of the languages subfield. So I want all of them to exist. However, I don't care if other things also exist in that. So here you can see the languages field. We have English and French. We have other languages. Again, for example, we have English and French here, English and French here. Here we have English, German, and French. That's still fine. So whenever we're looking for documents that have a number of items in there in one of in the lists for one of their fields, we can use the $all keyword. And in that case, it doesn't look for an exact match. Okay. Questions about this? Yes.
Using a logical OR with like language and like English or French, would that also return the exact same thing?
You mean if you change the order?
No, as in like without using the all operator, but using like an logical.
Okay. So we use a logical OR, and then we include both cases of the different orders. Yes, that will work. Yes. But it's, again, it will only return documents for which we have only English and French listed in them, in any order. Yeah, nothing else. So here the difference is that here we can have other languages. In that case, whenever we have something like this one, we're looking for an exact match. It cannot contain anything else. Okay, another operator that might be useful is the size operator, which looks at the size of the array. For example, here, if I want to return all the movies that have 2 directors, I can apply this size operator, equate that to 2, and apply it to the directors field. And now, all of these documents that are returned, they actually have 2 directors. Another useful operator for arrays. Okay, we have one more important operator for arrays, but let's discuss that after the break. So let's take 5 minutes, and then we'll be back at 8:45. All right, we're back. Okay, so have a look at this this data. Have a look at this data. So these are a few students, or maybe they've been students in the past, and they've got these grades. Okay, and you can see that for the grades field, I have an array to store their grades. Okay, so now suppose that I have a query like this. We want to retrieve documents for students who have one grade, at least one grade, in the 80-85 range. Okay, so in this particular collection that I have here, only this student, Varada, matches this particular condition. So she has a grade of 82, which happens to be in this range. Other students, Kwan and Florencia, they don't have a grade in that range. Okay, so I expect this particular document to be returned to me. Okay, so let's do it like this. So I say, okay, grades, and now I apply this condition, greater than or equal to 80, less than or equal to 85. And when I run this, all of those documents are actually returned. So this is obviously not the right way to do this. This is because when MongoDB applies multiple conditions on an array field, it actually looks at the array as a whole. So as soon as it finds one element that matches this condition and at least one element that matches the other condition, it will return that array to us. Okay, so for example, here we have these two elements that are greater than 80 and this element that is less than 85. And again, here that's obviously true. Again, this element is greater than 85, is smaller than 85, and these elements are greater than 80. So because there is at least one element that matches each condition, then MongoDB returns that document to us. So bottom line here is that MongoDB looks at arrays as a whole when you apply multiple conditions. As soon as this condition is true for some part of the array, it will return the document to us. But here we really want to look at each element in the array and then apply that condition onto that, right? We want this condition to be true for one element, not for a bunch of elements. So in that case, we have an operator called element match. And in that case, if we use it, it actually looks through the array and applies both conditions at once onto each element. And only if that condition is true, those combination of conditions are true for the same element, it will return that document to us. And you can see that in this case, this is the correct result. Okay. So element match, just like the name specifies, it looks at each element and applies all of the conditions on each element, and as soon as that finds a match, it returns the document to us. In the previous case, it was applying these conditions on all of the elements inside of the array. That was the difference. Okay, so this is an important operator actually. It is used quite a lot. Okay, any questions about element match? Before moving on to the next. Okay, now I guess this is the last thing we cover here about a different substructure in MongoDB. So one other structure that we can have in MongoDB, so far we have structures like subdocuments within fields, we have seen arrays within fields, and now we can also have a combination of the two for a field. So we can have arrays of subdocuments. So previously what we had was arrays of values, or we had just a simple subdocument with its own attributes, but we didn't have a combination of both. So let's look at the instructor's collection here. You can see this is me, the courses that I teach, department, this is Rodolfo, courses that he teaches, departments, stuff like that. Okay, now let's find instructors who teach 512. Okay, so courses, and the name algorithms and data structures and code 512. Okay, so that's the right result here. Okay. However, if we do something like this, this would fail because just like arrays, whenever we specify something like this, an entire like a filter on the entire subfield, then MongoDB looks for an exact match for the entire subdocument. So this doesn't work because it doesn't find any document for which we have code 512 for courses attribute. Okay, so the easier way to do this would be to use the dot notation. Okay, so the dot notation still works even if we have subdocuments within arrays. Let's have another look at the documents that we have here. So we have courses, and you can see that the courses itself is an array, and that array contains 2 documents itself. Okay, and each document has its own attributes. So this one document, and then this one document, right? And the whole thing is an array. And the good thing is that the dot notation still works, so we can do something like this: courses.code 512, and that returns the correct document for us. Okay. Again, very similar to arrays, if we have mixed conditions, then those conditions will be checked for all elements of the array, not just for one. For example, if I apply these conditions, courses.code 551, courses.name looks like this string that I have here, algorithms. If I run this, it will return this, even though there is no course in my collection that has the code 551 and the name that contains algorithms. Because again, just like arrays, it looks at the entire subdocument. It doesn't look for each subdocument. So again, we can use element match here as well, because this is still an array, although it contains subdocuments. So we can do this. Instead of writing it like that, applying multiple conditions, we can do element match and then apply the conditions inside of that operator. And when we do that, it looks for a course that has this code and this name, and obviously that doesn't exist. 551, it's the name of the course does not include algorithms. Okay. So that's it about various operators that are used for querying different kinds of structures of data in MongoDB. And before moving on to aggregation pipelines, are there any questions for what we have covered so far? Yes. Is there a reason that we're... Okay. So what is the reason that we call this thing, for example, the courses field, we call its value an array instead of a list? No, this is just like the terminology that MongoDB uses by default. They call it an array instead of a list. Yeah. Okay. So let's move on to the next part, which is actually one of the most desirable features of MongoDB, that is aggregation pipelines. Aggregation pipelines in MongoDB are a set of tools and a framework, basically, that enables us to do step-by-step processing of data in multiple stages, enables us to do complex analysis on our data, and makes us able to do exactly what we want to do. So it takes away the limits from order of execution or stuff like that, and enables us to do things that are really, really complex otherwise, or maybe impossible. So basically, an aggregation pipeline is nothing but stages of processing that are done on the data. We start from any collection, and then stage by stage we apply some sort of operations on our data. And whatever comes out of the previous stage goes directly into the next stage, meaning that the data is at this stage, for example, is the result of whatever processing has been done to the data in this stage. For example, if I remove some of the fields from my data, then at this stage I no longer have access to that. I no longer can, for example, sort my data based on that field or do any computations on that. So it's truly a stage-by-stage processing of data. Okay. So all of the queries that we have written so far can actually be written using aggregation pipelines, and I think actually that makes them very understandable, and it also makes them kind of universally applicable, meaning that the piece of code that you have works in Python, it works in Compass, it works in MongoDB shell, it works everywhere. So that is also a nice thing about it. Okay, let's see the syntax of an aggregation pipeline. In PyMongo, it looks like this. The important part is what goes inside of these square brackets. And those are the stages of processing. So the data passes through stage 1, then the results are passed to stage 2, results of stage 2 are passed to stage 3, and so on and so forth. Okay. So there are various different stages provided by MongoDB. I have included a link here that you can check out. Here I'm going to cover the most essential one, the most commonly used ones. And there is also a link here that shows a side-by-side comparison of SQL aggregations compared to MongoDB aggregations. So you have the SQL syntax on one side and then the MongoDB syntax on the other side. For example, here, select count is count from orders. It has, if you translate that to MongoDB, it looks like this. And we have a bunch of other, several different SQL syntaxes and then their translation into MongoDB query language. Okay, this is, I guess, pretty helpful. And you have a question similar to what we see over here. That's question 5 on the lab. Okay, so let's go back to the code. Let's start from the matching stage. The matching stage is actually the filter, what we used for the filter argument before. So exactly the same thing. This is what we use to filter the results based on a certain condition. For example, here I have the aggregate method here at the top. Here I have my square brackets, and all of the different stages of aggregation go here. Okay, so here I have the match operator, and I say only return documents to me in this stage that have the department.name equal to statistics. And this is what I get, name statistics, name statistics. So match is equivalent to what we've used for the filter argument before. It's exactly the same thing. Okay. Now, the thing is, when we use aggregation pipelines, we no longer have to do everything in one place. We don't have to write our entire match condition here. We can have several matching stages. We can have another one here, another one over here, and these can be different things, different conditions, basically. Okay, so that's matching. Projection, we are already familiar with projection. That means that we only select or pick specific attributes to be returned to us. And here, I'm matching the department name to be statistics, and then I take that resulting data and pass it through another stage. In this case, it's a projection stage. I turn off the _ID field, and I only retain the name field. So here you can see that only the name of the instructors is retained. Okay, stage by stage, matching first, projection next. Notice the square brackets here, and then the comma here specifies different stages. Okay, so with this projection operator or stage and aggregation pipelines, one interesting thing that we can do that could be very helpful is subfield promotion, and what is that? So take a look at this aggregation pipeline. Here we have the projection stage. We're turning off ID, retaining the name, and then I say, okay, look at what's stored inside of the department.name attributes and store it as an independent attribute in the results and call it department name. And notice whenever I want to do that, I want to refer to a particular attribute, I have to use the $ here. Okay, that's the $ there. If I do that, now you can see, okay, it has returned the name of the instructors. However, it has also extracted department.name and has assigned it to a new attribute called the DEPT name, department name. Okay, so that's one useful thing that we can do using projection. Okay. This can be helpful, for example, if we have documents that have very complex structures and we have to reach into nested subdocuments to retrieve the values of some of the fields. So we can just promote those fields and we extract them out and we put them inside of the main document, the main level, and then we can query them more easily. All right. Again, don't forget the $ here. Yes?
If there are multiple values within the same sublevel, would they be repopulated as one per row, or is it just altogether?
Oh, no.
Or like
Okay.
director names?
Right. Okay, so the question is, if we have multiple values listed for this department name, let's say statistics and computer science, what would happen in that case? So we will still have the same array appearing in the main level. If you want to take those values out, that is a different operator that I'm going to talk about in a bit. Okay, another thing that we can do using the projection stage is to do what we used to call derived columns, meaning that in SQL we could, for example, multiply values of a particular column by a number, add two columns together, and stuff like that. This is also possible using projection. So here again, I'm turning off ID, returning title. However, I'm multiplying imdb.rating by 10 in order to have that rating out of 100 instead of out of 10. And you can see that we see those ratings out of 100. You can see that I've defined a new field. And for that new field, I'm using the multiply operator. And I'm multiplying this field by this new value, 10. And then I'm assigning that to a new field called rating out of 100. Okay, so this is one other thing we can do using projection. So it's exactly similar to, like in SQL, if I say select column A multiplied by 100. So syntactically in SQL it looks much simpler. Here this does the same thing, but its syntax is looks a little bit more complex. Okay, so that's projection. Sort, limit, skip, they work pretty much in the same way that we are used to. Limit for returning certain numbers of documents, sorting, that's just sorting, and then we can apply them in stages. That's the only difference that we have here. So here, I use the matching stage to filter out certain documents, and then I project some of the attributes, and then I do the sorting, and finally the limiting. And in this case, note that the order in which we do those operations actually matters. This is probably one of the most important things about aggregation pipelines. For example, if I do limit before sorting, then my sorting will be done only among 10 documents because I have already only retained 10 documents, and then I'm passing it to the sorting stage, so it only sorts 10 documents. However, if I do it like that, then in this case, it sorts the entire collection first based on imdb.votes, and then only returns 10 documents. So this is very, very important because in aggregation pipelines, it's up to us to decide what is the order in which I want the documents to be processed by different stages. Okay, questions about this? Yes?
So are aggregation pipelines the ways that can somehow bypass the order of execution?
Exactly. exactly. So there is a default order of execution, filtering, and then projection, and sorting, and limiting. But here, it's all up to us. We can override that as we wish. Yeah. One thing that's very important is that, for example, here I've projected only to have the title on imdb.votes. In this case, I can no longer, for example, sort based on imdb.rating because I don't have that attribute anymore. That's very important. Okay. So the count stage, really straightforward. It just counts the number of documents that have been passed to this stage. Simple as that. Now, the group operator, this is exactly the same thing that we have seen in SQL when we use the group by clause. So basically, it groups by values inside of an attribute, and then you can apply some accumulator function onto those groups. That's exactly it. Okay, so for example, suppose that here I want to count the type of, I want to count how many movies I have, how many TV series I have in my movies collection. So the syntax is like this. I have this group operator, and then this underscore ID is we have to have that particular field. It specifies the column by which the column on which we want to do the group by. Okay, so group by the type attribute, and then here we have our accumulator. So for example, I say that I want to have this particular field in the output, and for its value, I want to sum the number of documents that I have for each group. Let's take a look at the results, and it makes more sense if I show you them. So you can see that I have two groups only, series and movies, because those are the only two values that exist in the type attribute. And then for each one, it has simply summed the number of documents for that particular subgroup. So again, it's exactly similar to the group by clause in SQL. Okay, this ID again, this is something that we have to have there. We cannot rename to anything else. It's a way to tell MongoDB what is the column that I want to do the group by using that. Okay, yeah.
How can we do group by multiple fields?
Group by multiple attributes. I guess we can do something like that. I think maybe if I'm just guessing, I'm not entirely sure. Maybe we could put this into a list or something. IMDb. No, let's do title. Okay, so it works. Yeah, perhaps we can do something like this or a variation of this, putting things inside of a list. Maybe a list is not a good idea because it might look for an exact match. So you have to be sure about this. I haven't tried this ever, so. Yeah. But there's certainly an example about this in the documentation. Okay. All right, so this is group by. Now, another very important operator is the unwind operator. And this relates to a question that was asked before. So if we have a field that contains several items, how is it possible to extract those items and put them into the main level of the document? Okay, so suppose that I want to obtain the average IMDb score of movies played by each actor or actress. Creating a grouping stage like this one wouldn't work. So suppose that I want to group by the different actors, actresses, and then find the average IMDb scores. That would be an interesting query to run, right? So if I do group by, in that case, because the cast is an array, it wouldn't work as we want it to, because it will look for an exact match. However, there's an operator called unwind, which what it does is basically it looks at an array, extracts each item from the array, and then creates a new document with that particular value. Let me show you an example here. So we have these students inside of the MDS collection, very simple documents, the name and the grades. Okay. And now let's apply unwind on the grades. So basically what it does, if you look at here at the results, it goes inside of that array and then takes each value out and creates a new document only with that value for that particular field. Look at this. So Kwan with this grade, Kwan with this grade, Kwan with that grade, Varda with that grade, with that grade, with that grade, Florencia again, 3 documents for Florencia. So for each one of these elements, we will have an independent document. So everything else is the same. It only basically deconstructs that array for us. Why is it helpful? Because we can do group by. Once we have access to these information, we can just simply do group by student name and then obtain, for example, the average of the grades, right? But previously, that wasn't possible. So again, take a look at the documents here. This is an array. We just want to deconstruct that, and the unwind operator achieves that for us. So with Kwan, we have 3 grades, and we will have 3 independent documents in the results. Okay, now that we have done that, so we have an unwind stage here. We have deconstructed the grades attribute. Now, I can group by the name, and then I can take the average of the grades. Simple as that. Okay, now this works because it simply runs a group by on these results, right? And it simply computes the average for each subgroup of values, right? Like that. Questions? Yeah, okay, good question. So if we have an array of subdocuments, then what happens in that case? Do we have to do the unwinding to reach into the different levels? Yes, so basically when we unwind, we only unwind one certain level, and then if the element that we're looking for, the field that we're looking for is not there yet, we have to do another stage of unwinding to basically extract everything that we want. Yeah. Any other questions? So whenever we're dealing with arrays, then we can use unwind in order to make it possible for us to do grouping operations of accumulating values. Yes. Oh, okay. So the question is, why are we using this sum by 1? So this is just simply the way that MongoDB group by works. I can actually use other values, 5. It just, every time it sees one of those documents, it just adds that value to the existing result. So if I use 1, that actually amounts to the count of those values. But it's up to us what value to sum up. So it's like a running sum. Yeah. All right. Okay. Yeah. We're good on timing here, so this is it for the lecture, for the final lecture of the course. Are there any questions about this lecture before talking about other stuff? All right. Okay, so we are basically done with the course except for Lab 4 and Quiz 2. So in this course, just to have an overview of what we have done so far, we have talked about the concept of databases, why we use databases, and what are the things that databases enable us to do that would otherwise be impossible or hard to do. We have discussed that in lecture 1. Then we've discussed about basic SQL syntax, and then we moved on to learning more about how filtering is done, deriving columns, and then finally we reached the topic of joins, which is the most important kind of operation in relational databases. And then I started introducing you to defining, or maybe we could say modeling data, not exactly, but I have introduced creating, modifying tables, and then another important topic we discussed there was integrity constraints, which is again something very important when we talk about relational databases. Then we touched on transactions and ACID properties of databases. And then finally, we talked about subqueries. And in lecture 6, we talked about a bit more advanced operations like window functions, common table expressions. We talked a little bit about views, and then a little bit also about indexing and query optimization. And finally, we ended this course by talking relatively briefly about NoSQL databases and talking about a particular example of NoSQL databases, MongoDB. So in this course, what I wanted to do was to focus, as much as I could do, I was to focus more on the concepts rather than just syntax, just giving you syntax and work on the syntax. I tried to basically explain why using databases is needed at all and how this concept of databases applies both to relational kind of data and also to non-relational kind of data. And also, I've introduced you, we've discussed a lot the concept of databases and the kind of things they enable us to do in the beginning. And then you saw that all of these also applies to other types of databases. So this course pretty much covers, I would say, almost everything that you need, at least for your job interviews. And also, as far as I know, pretty much anything that you need as a data scientist to know about databases, unless you decide to develop an expertise in databases. So this is why we've kind of covered a lot of topics. I could have gone slower with a slower pace and then cover much less, but this is not what I really wanted to do. I know that I could have included worksheets during the class. If I had done so, we would have covered much less in this class. So this is why it might have looked a little packed, but I wanted to make sure that you have an idea about most of the important topics that I think are important for your career in data science. Okay, if you're interested in knowing more or you're interested about certain particular topics in databases, you can reach out to me next week and you can ask me for references. I'll be happy to provide you with some extra references or point you in the right direction. Otherwise, I have also listed some suggested material here. I really love this book. This one, Visual Quick Start Guide. If you happen to forget about SQL in a few months and you want to have a quick review, this is an excellent book. It is relatively short, but it's one of the best books out there for basic SQL. If you want to go a little bit more advanced, you can also check out the Classical Database Management Systems textbook over here, which is a textbook that people use for an undergrad course in databases. And if you're also interested in more niche topics on databases, then you can reach out to me. I'll be happy to help you with that as well. So I enjoyed a lot working through this course with you. I hope if you already were familiar with databases, you learned something from this course. And if this was the first time, I hope it wasn't too difficult, too hard to digest, and it was something useful for you too. So thank you, everyone. And I'll see you either in the lab today or next week in the quiz. Thank you.